As in the last lecture, we discussed about the interference and we did derive the formula for the interference. So now the next thing is in the interference, we can have main two types of interference. One is the constructive interference and the destructive interference. So before going on to the mathematical expression and the mathematical condition for these two interferences, I want to show you something here. So like here I have taken, as you can see on the screen, there are two pulses which are traveling in the opposite direction, and right now I have taken that the height of both of the pulses is 2 and width is also same, and they are similar. Okay, I'm using this term similar means that if you look at the pulse one, it is traveling in the right direction, and the pulse is above this line. And if you look at the left pulse, so if you look at that second pulse, that is traveling in the left direction and that is also above this line, so both are having kind of same phase. All right, or otherwise I can say they are similar. So when I move these pulses, when they interact with each other, so then they are going to go like this, and when they meet exactly, if you look carefully, what is happening is that their total amplitude is simply added. So now if this amplitude of both of them is 2 and 2, so then the total amplitude will become 4. So this is one kind of interference where the superposition, where the two waves are coming and they are meeting in such a way that their amplitude is added. This is called as constructive interference. Alright, so where we can see the constructive interference, like when you drop two pebbles in a water tank and these two waves are interacting in such a way that the resultant wave is a higher wave. So that is kind of a our constructive interference. One more thing we can take, like for example in the sound waves, when the two sounds are coming from the two side directions and they are interacting and the amplitude at that point is maximum, that is also the example of this constructive interference. Or otherwise we can take one more example of our light, when the two lights are coming from the two slits and they are interacting with each other and there is a bright spot with the maximum intensity, so then that is the constructive interference point. So wherever we in the Young's double slit experiment will say that wherever there is a constructive interference, at that point we'll get the brightmost point at that point. Okay, now let us take the other kind of interference. I'm changing the height of the first pulse. Let us make it negative -2. Okay, all right, so let us again simulate this. So when I run this simulation, if you can see, this is how they will proceed, right? Okay, let me just show you at the point where they are fully interacting into each other. Look carefully. The this pulse is going in the right direction and the right pulse is going in the left direction. At this point they are meeting in such a way that this string becomes straight, right? This string is straight and resultant amplitude becomes 0. That is our destructive interference. So these two waves of amplitude, they can also be of different amplitude, then of course the net amplitude will not become 0, but here I'm taking the equal amplitude. So if the two waves are interacting in such a way that the amplitude are subtracted into each other, then that is the destructive interference. And that is why if you take the Young's double slit experiment, in the Young's double slit experiment, we'll take the two slits and these two slits light will be coming from the common source. So that's why the amplitude of the both of the slits will be equal. That's why when they do the destructive interference, at that point we'll get the 0 intensity, right? Or the 0 amplitude, or because the intensity is proportional to the amplitude is square, so that's why intensity will also be 0. So that's why at those points we will get the dark point. There will not be any light at those points.